ABAC and XACML Made Easy webinar using ALFA to write fine-grained authorization policies. Let me introduce the speakers. My name is David Broussard. I'm the head of customer relations for Axiomatics. I've been working on security and federation for the past 5 to 10 years in that space, and I realized that I should have been polite and introduced my colleague. Good morning, Jonas. Jonas is our VP of Sales Engineering. He's based out of California, and he also brings a baggage of a lot of security experience, having worked for a wide range of security companies in the past and with Axiomatics for the past 3 years. So Jonas and I will be taking good care of you today. And on that note, let's go ahead and get started. So let's have a quick look at the agenda. I'll go ahead and start everyone off with a quick intro to ABAC, XACML, and ALFA to get everyone on the same level. And then Jonas will take you through the basics of the ALFA syntax and language, and will also walk us through an HL7 example. For those of you not familiar with HL7, it is a healthcare standard here in the US and around the world. As a matter of fact, it's an international standard. Then Jonas will pass it back to me, and we'll discuss some simple best practices around your ABAC policies, making your authorization policies more efficient and better structured. And finally, we'll look at how to deploy your policies programmatically to the Axiomatics Policy Server. And let's kick it off with a bit of background on ABAC, XACML, and ALFA. We sometimes call that the acronym soup. We love acronyms here. So ABAC stands for Attribute-Based Access Control. It's a standard that's been recently formalized by NIST, the National Institute of Science and Technology. But as a matter of fact, it's a principle that goes way, way back. With ABAC, you can define fine-grained authorization in an externalized fashion. When we say externalized, what we mean is that you've successfully decoupled your authorization from your business logic. You've actually separated your application logic from the authorization logic. When you do that, when you successfully decouple the two, you can then centralize your authorization logic into a single point. So that's the second aspect to ABAC, is the ability to centralize that authorization logic. Now, of course, the name attribute-based access control does indicate that ABAC is based on attributes. And that's actually really important. Attributes are just key value pairs. You'll see that when Jonas writes some ABAC policies later using ALFA, we use attributes all the time. A key and a value. Example, role is equal to manager, citizenship is equal to Swedish, location is equal to Chicago, so on and so forth. And since we use attributes, we can combine these extremely easily inside policies, which is also why we claim that ABAC is policy-based. And one of the key benefits to using a policy-based approach is that the gap between the original authorization requirements and the technical implementation gets smaller and smaller. We're closing the gap, we're bridging the gap between business requirements, authorization requirements, and technical implementation. So to sum it up, ABAC brings you 4 aspects. Number 1, externalized. Number 2, centralized. Number 3, policy-based. And of course, lastly, as the name indicates, attribute-based. Some of the benefits of ABAC, of course, are a better management of your authorization, better security, and a more efficient development environment. Now, my colleague, Jonas, go ahead.
I was just going to chime in and say a real powerful aspect of that is the fact that attributes are leveraged and used for the authorization decision, coupled with the policy, is that in many, many cases we see that the policy becomes very static. And what changes in the environment is the attributes. But they change regardless, right? Because the attributes come from your underlying data sources like Active Directory or an HR system or something like that. And if a user within an environment moves to a different department or changes a cost center or what have you, that is pieces of information that changes regardless. and an ABAC system leverages those attributes, and the authorization outcome is different when the attribute changes.
Yeah, that's a very good point, Jonas. So number one, we use attributes that exist naturally, such as your department or your role or your citizenships. These are not things we invent. These are attributes that already exist within the ecosystem. Here in the example you'll be using, Jonas, you'll be using attributes of medical records. These are information that already live within the health database. The other aspect that you said, Jonas, is a very, very good point. Policies are relatively static. They do not change much. Policies are like the law. The law doesn't tend to change every single day, but the values of the attributes do. So the fact that you're a manager, that might change every single day. Your bank account balance, that definitely changes every single day. The policy about who can view a bank account doesn't tend to change that much. Now, our colleague Jerry and I spoke about ABAC and compared it to role-based access control in a webinar a couple of weeks ago. So if you want to learn more on ABAC and RBAC, do turn to that webinar. You can watch the recording on the Axiomatics website. Now, ABAC is great. It's a model. Gartner recently said that 70% of enterprises would adopt ABAC by 2020, so it's a very fast-growing environment. That said, we do need to have a technical means to implement ABAC. And that technical means today is XACML, XACML, or Extensible Access Control Markup Language. Now, XACML is a standard that has been developed by Oasis for the last 13 years. Even a little more than that. The first time it became a standard was in 2003, but work started before that. And what XACML does is it provides an architecture. It defines the ABAC architecture with the notion of a policy decision point, with the notion of a policy enforcement point. It defines a request-response protocol. In other words, how you ask for an authorization decision and how you get an answer back. In today's demo, Jonas will show us the JSON version of that request-response protocol. And finally, but perhaps more importantly, it defines the policy language, how to encode your ABAC policies into a language that you can then execute within your technical environment. Finally, in this webinar, we'll look at ALFA. ALFA is the Abbreviated Language for Authorization. It's a standard that we invented at Axiomatics and then donated to Oasis a couple of years ago. So right now it is a draft within the Oasis XACML Technical Committee. And Axiomatics also developed a plugin, which we'll be using today to write the policies, that plugs right into your Eclipse IDE, and which will help you write your ALFA policies. So over to you for the basics of ALFA, Jonas.
Yeah. So yeah, that's sort of the core part of what we're looking at in this webinar, right? So we through the basics of ALFA, and we'll look at some samples, and then we're actually going to go in and write some policies live using the very Eclipse plugin that David just mentioned. So ALFA is a simplified C#, almost Java-like language or syntax, which obviously makes it very easy for developer-type personalities or anyone with some development skills to actually understand and get into. It uses a namespace approach to organize your policies, and with this makes it very easy to obviously scale to a large number of policies, and we'll see that even though obviously writing live policies on a webinar, we won't be able to write hundreds of policies, but we'll try to express them in a way that you can see the structure and how that can scale. And as we write these policies, we'll also look at how easy it is, because this is essentially like writing C# type code. It's very easy to add comments into sort of the alpha source code that we're working with, which obviously makes it easy to follow along and understand what certain policies are doing in a very easy way. And when it comes to the technical specifics, all the main sort of keywords of XACML are available within ALFA. So we're not going to get into the details of XACML policy language here necessarily, but a couple of the aspects and building blocks are obviously the policy set, policy, and rules, and we have all the combining algorithms. We deal with and define targets and condition, and ALFA also obviously supports the definition of obligations and advice that can be specified within policies, and return information essentially back to the calling entity being referenced as the policy enforcement point in the XACML standard. So there's more details of ALFA on Wikipedia, and as well as Stack Overflow. As
a matter of fact, Jonas, we welcome contributions from everyone on both these pages. Everyone is welcome to enhance the Wikipedia page with more examples. And if anyone has questions or knows answers relating to ALFA and XACML, they can post them and reply to them on Stack Overflow. There's quite a few questions already out there.
Absolutely, and we monitor that too to kind of help answer some of the questions and clarify things. So the ALFA plugin for Eclipse provides an editor inside of Eclipse for ALFA, and you will see the practicalities of this, but it provides the syntax coloring and autocomplete capabilities and features within Eclipse. Obviously, syntax checking. So there's that on the ALFA code in itself. It will tell you if you do something wrong, and since we're doing this live, I'm sure we'll see some potential examples of that too as we go along. What happens within the Eclipse plugin is that as you're writing your ALFA code, it will on the fly essentially translate that ALFA code into XACML 3.0 policies or conformant code. I sometimes refer to it as the ALFA plugin compiles it into XACML, but that's not necessarily entirely true. But we will see examples of this too as we go along. We'll see the actual XACML artifacts being generated, and like we saw on the agenda, we'll also talk a little bit about how we can automate the push of these policies into our Axiomatics Services Manager tool, our centralized management tool. And those are the actual artifacts that we do push into the centralized management, and that's in the end used by a policy decision point, PDP. So ALFA is just sort of it's a higher level language that is easier to express, but what we are actually wanting in the end are these XACML artifacts, right? Because that's what the PDP in the end will use. And then we have a link here. We are recording this, so you can obviously see this in the recording too, or take a note of this URL here. That is where you can get the free package of the plugin for Eclipse and download that.
So we had an interesting quote from one of the analyst firms in Europe called Cooper & Cole, who are the leading identity and access management analyst firm out of Europe. And Martin Coopringer, who's the founder, wrote in a blog post on his on the website saying that ALFA is a pretty nice tool which closes a gap around XACML development. Programmers can create policies the way they are used to in an environment they're used to. And that relates to what Jonas said. I mean, first of all, the ALFA syntax is very C# and Java-like, so it's quite easy to understand, and you'll see that live in the demo. And secondly, you don't have to use yet another tool. You just put the plugin inside Eclipse, and you're good to go. So it reduces the number of tools you have to handle, and that makes it, I was going to say more fun to use, but perhaps more efficient is the more adequate word here. What do you think, Jonas?
Yeah, if you don't require a point-and-click tool, yes, for sure, efficiency is definitely there because you get all the nice things that you can do with sort of raw, essentially source code, right? Because you get the autocomplete, but you also get the ever so used Control or Command C and Control V, Command V options, where you can copy and paste big chunks of code if you need to reuse some snippets and pieces, right?
And another great quote we had from Gartner, another analyst firm whom you all know, is the following: simplification of policy expression using XACML is an area that will continue to mature over time with initiatives similar to domain-specific languages, such as ALFA, the Abbreviated Language for Authorization. I think the point here, Jonas, that Haman is making is that in order to make ABAC easier, we need to work on simple, lightweight languages, and ALFA is one such lightweight language.
Absolutely, and it's sort of about driving the nature of this forward, right? But it should also be mentioned, even though this webinar talks specifics about ALFA, and I specifically mentioned, if you don't like point and click, ALFA is great, right? But it should also be noted that we obviously at Axiomatics provide additional tools for authoring policies, so ALFA is not the only way. It's a great way, and it's an alternative way of expressing policies, but we do also integrate it inside of our management system, have a point-and-click tool and a UI-based web tool to express these policies. But the cool thing is that you can start defining policies in ALFA, and you can actually then move those policies into a UI-based tool and continue the authoring there. So you don't lock yourself in one place, and that's obviously because the underlying piece is the XACML policies, which is standardized. Now, so if we go in and look at an example of a policy, we'll obviously see more of this, but to just kind of start off with seeing what the building blocks for an ALFA policy are, the first piece is the way policies are structured. And we use the elements, obviously, that anyone that is somewhat familiar with XACML know of, which would be the policy set, a policy, and a rule. And so you can see here how those are defined. We have sort of the root of this is a policy set that deals with, or the name of the policy set is medical records. And you can also here at the very top see what a comment in the ALFA code looks like. You can see that between the /*, we deal with medical record policies. There is within that policy set a policy for physician access medical records defined, and then within that policy there is a rule that says read medical record defined. We'll go into some of the other building blocks here in a minute, but the point here being that you can structure the policies in a nested way. There are specific rules within XACML and how you can do this. Obviously, a rule cannot reside directly in a policy set, and you can define, for example, multiple policy sets nested. So a policy set can reside inside of another policy set, and so forth. But this is sort of the basic structure.
So it's fair to say, Jonas, that the same rules apply to XACML and ALFA with respect to how the structure is built.
Absolutely correct. Yes. So if we break it down and look at the other components here, we obviously have the combining algorithms, which are ever so important in how you structure your policies and essentially what combining algorithms you use, right? So in these two examples here, we have the first one is using a first applicable combining algorithm, and the second one within the policy, you can see that there is a deny unless permit combining algorithm. So these are the conflict resolution pieces within XACML policy. So the first applicable is just like it says, if there are conflicting decisions within that policy set that we eventually get to, the PDP that evaluates the policy is then going to use the first one that is applied, essentially. Actually, what it means is if it finds a decision, it will use it and then sort of break out of the evaluation. Deny unless permit is obviously a little bit different, because there you need to first figure out, is there ever a way for me to get a permit decision? If I don't get a permit decision, I should return a deny decision. We do actually, and unfortunately we don't have a link in here, but you can find on our on the Axiomatics blog on our website, you can actually find a very, very good blog post written by you, if I'm not mistaken, David, that describes all of these combining algorithms and exactly how they operate in various scenarios.
That's correct. It's I call it combining algorithm truth table, because it explains how they apply to different policies and policy sets and how the effects get combined together. So you can look it up if you search for combining algorithm truth table.
Last piece here is the targets. These are the pieces we use to define the scope of a policy or a policy set or a rule. So obviously this is where we sort of guide the evaluation path within the policy decision point when it evaluates against the policy, and we tell it, go down this branch of the tree, or go down this policy set for this policy. So if we get a request in that deals with an object type assessment note or something like that, then there's no point in evaluating policies that deal with medical records. So that's what we're doing here at the very top level at the policy set. We're saying, if the request that comes in is asking for access for the object type medical record, then yeah, drill down this policy set and continue. If we're not, there's no point in evaluating this policy, because there's probably another policy set that deals with asset notes. And targets are, as you can see here, we're doing a static mapping, right? And this is the attribute. A better example of that is within the policy here, where we're saying user.role equals physician. So we have to get the role from, in that case, from somewhere. What typically happens is that we see in the request some type of user ID, and then we can determine the role for that user. It could be multiple roles. And if that role is a physician, then we can keep drilling down that specific policy. But in a target, we do a fairly static mapping, as you can see. And targets are very, very fast for the PDP to evaluate. But you'll see an example, and I don't think it's highlighted here. In the condition, you see in the rule there's a condition where we are saying the primary physician equals requester ID. In that case, it's not a static mapping. It's actually doing similar to what we're doing in the target, but it's comparing two different attributes. So that can be very, very dynamic information. The two attributes the two attribute values can be resolved from different sources, for example, and they are compared. And if they are equal, it's going to end up being evaluating to true, and that's when we at the bottom get to the permit decision, which is.
So Jonas.
Yep.
I want to highlight what you just said here. The ability in the architecture, in ABAC and in XACML specifically, to retrieve additional attribute and attribute values from external sources at runtime is what makes the language so powerful. So when you send your authorization request, like you explained, you only need to send in the key attributes, your user ID, your resource ID, your action ID, and then the rest can be figured out at runtime through the use of those external attribute sources, the policy information point. That makes the language very powerful, and it makes it very decoupled from the applications you're protecting.
Exactly. And I was speaking a little bit ahead of the slides here, so we can see here is the condition pointed out that I mentioned. And lastly, we do have the effect of the rule, whether it's permit or deny, which is essentially the two different decisions we can see. There are two additional not applicable and indeterminate as well that could be returned back, but not applicable typically happens if you do not get a decision back. There's no policy that applies to the question that you're asking. It should be noted, though, that a decision, the effect, can only reside within a rule, obviously. So the rule is where the decision actually happens in the end. The policy and the policy set are simply sort of filters on the way to get to the decision. Okay, so we are going to use ALFA to implement well, it's essentially it's a core HL7 policy with an addition, we can say. And HL7, for those who don't know, we just picked HL7 as a way to simplify this. Obviously, this could be modeled in any type of policies can obviously be modeled in ALFA, but we figured we'll pick something that's already publicly defined in terms of use cases. And there is an HL7 wiki that we have a link to here that defines these use cases. So a little bit of background on HL7 is the security and privacy ontology around healthcare, and defines standardized ways for healthcare systems to communicate with each other and transfer of information in a standardized way between healthcare systems and different healthcare environments. And as you mentioned, I think earlier in the beginning, HL7 is an international standardization organization that I think has presence in 40 different countries at this point. So it's globally used and a fairly well-used standard within the health industry.
And it covers, like you said, it's not just security, of course, it covers other aspects, such as the standards for the electronic health records and other data within the healthcare industry.
Exactly. So we are going to look at a specific one that talks about or defines sort of access to a medical record. So the background for what we are looking at here is the Shady Grove Hospital, which has developed an access control system that implements decisions made in its security policy on its EHR system. And this sort of specification and the way this use case is defined is publicly defined by HL7. So these use cases are not something that we made up. They're actually available. I think they have 7 core use cases defined there. The security policy grants the primary physician access to create and update a patient's medical record. That is the actual core use case that we're going to implement in ALFA. And if we look at that statement, the security policy grants the primary physician access to create and update a patient's medical record. We can kind of break that out. And this is where we take what we typically refer to as a natural language policy statement, and you can almost say that we ABACify it or whatever term you want to use, but we look at the statement and we start identifying what out of these pieces within this statement are attributes, right? So a physician, well, a physician is obviously some type of role here, can read and update. The read and update statements are different actions. A patient's medical record, well, that's the actual object that we're working with. So the read and update could be changed with create and delete, for example. That would be different types of actions. And the medical record, which is the object, in our case, could be changed to an asset node or some other type of object. If they are the patient's primary physician, so that's kind of it's a care relationship in this case, but it's important to point out that it's a relationship type of statement, right? Because there's a relationship between the patient and the physician in this case, and the fact that the physician is the patient's primary physician. And it's an important aspect to look at because this is one of the powerful things that can be modeled in an ABAC, an ABAC world, and it's very, very difficult, if not impossible, I would say, to model in a role-based access control model. Okay, so let's look at this and what we can, how we can model this within ALFA. I'm going to switch to my Eclipse plugin here, and
Becky's birthday, Jonas.
it's an important one because it's my mother-in-law. So.
Oh, well, happy birthday, Becky.
Yeah, exactly. So I've somewhat cheated a little bit here, just a little bit, not too bad. We should open this file too. I have started the basis of this policy just in order to save some time, and I'll walk through sort of the structure here. It begins with a namespace, and we have the root namespace here is just defined as com.axiomatics.hl7. I do a couple of imports here, and this is essentially to import some of the attributes that I've already defined, and these attributes resides within different namespaces. The bottom one here that looks different is importing the standard attributes that come with the XACML framework. And then I have already defined a policy set that you can see here, which is my global policy set that I've named it global. Within an XACML infrastructure, XACML policy, you have to have an entry point. There has to be only one entry point because otherwise the decision engine will get confused. If it's multiple entry points, it wouldn't understand where to start, right? So there can only be one entry point, and that's what I've defined here as my global policy set. And further down here, I've already defined a policy set for medical records because I knew obviously what the use case was going to be about here. So here we see a comment that I've defined the entry point of the policy. This will actually also follow along with the XML or XACML artifact that gets generated from ALFA. It will be a part of the description of this policy. So it's not something that only resides within the ALFA code in itself. Within the medical record policy set down here, I have already defined my target clause. So we have already defined that I'm dealing with an object type of medical record. And I have also already entered my combining algorithm here. Now what we can do here and what we want to do is we have the entry point, but right now the entry point won't lead anywhere. This is essentially what the decision engine would evaluate at this point, and it doesn't do anything. So we need to tell the global policy set that once you start evaluating, go somewhere. And this is where we can actually reference other policy sets or policies within our ALFA code here. So we're going to see the first example of autocomplete. So if I start writing med, for example, and then do control space in here, I'll get an option for what things can I reference within my ALFA code. And I already have a policy set called medical record that I can reference. And with doing this, now we've all of a sudden told the root policy to execute or reference this specific policy set, which is our medical records policy set down here. And right now that doesn't do much either, but that's what we're going to implement. So if we start looking at the actual policy that we want to do, I've copied the statement down here so we have it available. A physician can read and update a patient's medical record if they are the patient's primary physician. So if we start implementing that policy, we can start by defining this as a policy set. We can call it physician access, for example. And as you can see, we now get sort of an error here from the Eclipse plugin, and that's because we are missing some aspects of what is needed inside of a policy set. And you can actually do a control space to see what are the different pieces that could go in here. And what we are missing above all is the fact that we don't have a target defined. And in this case, we are creating a policy set that is for this specific use case, and I'm going to define this as this. We've already noted that we're dealing with a medical record, right? So we don't really have to do that. That's within the medical records policy set up here. And what I am going to do is I'm going to reference my physician access policy within this medical record policy set. So what I want to do here is define the fact that now we're dealing with physicians. So what we first want to do is sort of filter that out, that if you're not a physician, we don't even have to drill down into this branch of the policy. So I want to determine here that we are dealing with a user that has the role physician. We're still getting a warning here, and that is because we're missing the combining algorithm. So you have to have a combining algorithm. We can just pick first applicable. Actually, I can do this to show you that here are all the options of combining algorithms that ALFA shows you. This is also expandable. You can actually define your own, obviously, combining algorithms within the XACML architecture.
Right, which is actually why XACML is called extensible, because you can extend its functionality by adding new data types, new functions, and in this case, new combining algorithms.
Exactly. In our case, the policy is not tremendously complex, so for us, first applicable would work fine. Now you can see I'm not getting any warnings anymore. These are sort of the bare minimums that we need in order for the alpha code to be complete. We still don't get to a decision, obviously, and we'll get to the implementation of that. But what we can do now is, from within our medical records policy set, we can now further reference our physician access policy set. So now we have sort of multiple stages here, right? We have the root that calls the medical records policy set. We have the medical records policy set that references the physician access policy set. And this is where we will now continue to implement our use case here. So we have already determined that we're dealing with a medical record. We have determined that we are the user is a physician, right? So then we have read and update. So if we start looking at that, we can then implement a policy that we can call primary physician. And again, we need a combining algorithm. But within this, we can now define two rules. We can call one read, for example, that will be dealing with the read action. And this is where we define then that this rule is specifically for the action read. So we can then look at an attribute called action, and we can say if the action is read. But we also want to define this relationship, right? So we got the patient's primary physician. And like I mentioned before, that is something that we compared, where we compared two attributes. It cannot be done in a target. A target is only operational for doing sort of a static comparison, where you have an attribute and a static value, like in this case. And the condition we can compare to different attributes. So we have our primary physician attribute, and we have our requester ID attribute. Now, what's happening here is that there is a notion somewhere in our system that specifies who is the primary physician for a specific patient, right? And then there's the notion of...
Sorry, I was going to say that's part of the information model in the application's backend.
Exactly. That is typically something that would be sort of resolved by the authorization engine at runtime, like you mentioned before, from an underlying data source, for example. And then in this case, we also have a user that is actually using the system, that is requesting to, in this case, read the medical record, right? And that's noted by the requester ID. So if the person actually trying to access the medical record is the same as the patients that we're dealing with, the patient that we're dealing with, primary physician, then this is going to evaluate to true, and we get a permit decision. Now, we have only defined the read rule here, but we are, in the use case, we can see that it says read and update. So we're missing the update part. Now, there would be two different ways of doing that. You can actually add an or statement here and say that action would be update. Or if you want to structure the policy slightly differently, you can actually, and this is sort of one of the nice aspects of ALFA, the copy and paste aspect, you can define a separate rule like this, where it makes it fairly clear that this is the rule that deals with write and this is the rule that deals with read. Now, you could obviously implement different type of targets and maybe more complex or different types of condition statements for these two different scenarios as well. Here you can see they become fairly similar, at least the condition statement is identical between the two, right? So this actually concludes sort of the use case that we have up here, right? A physician can read and update a patient's medical record if they are the patient's primary physician. Now, what if my doctor is on vacation? So the policy that we have implemented would then not allow any other doctors to actually access my medical record, because you have to be my doctor's primary physician. Or yeah. So how can we sort of handle an exception case? Well, so a physician can read an medical record if they are on the patient's primary physician's list of alternate privileged healthcare professionals. Now, this is wording taken from the HL7 standard and the HL7 use case. It's a little bit heavy, but we'll look at that it actually is fairly simple to model in an ABAC role. And if the primary physician is on leave. So there's obviously sort of a, we can see similarities, just like a break the glass type of scenario almost, because there's an additional statement here, right? If my physician is on leave, then some other healthcare professional can actually access my medical record. But if my physician is back or not on leave, then this alternate privileged healthcare professional cannot access my medical record. So if we quickly look at what that will look like within...
Jonas, just quick heads up, we're 12 minutes to go, and we want to save some time for Q&A.
Yep. We'll implement this very fast here.
That's actually one of the neat things of ALFA, is that you can do it very quickly.
Yeah. So the structure here is actually going to be very, very similar. So we first have a target, and in this case, it's going to be defining read or the action write, actually update. And we got the combining algorithm that we need. And then we're going to have one rule in here. And the rule is going to be slightly more complex than what we saw before. It's going to be a condition statement that uses a more advanced function. And it's something called string is in. So we're going to check that if the requester, which is the user using the system, right, is within the list of alternate physicians. So there's a definition of that within our underlying system here. this is where we looked at, is the actual user that's requesting the information in the list of approved alternate physicians. But there's also a date aspect here. My primary physician is on vacation, right? So there's a definition of when that vacation ends within our system here that we've defined. So if the current date is less than the vacation end date, then we should be okay. That means my physician is still on vacation. And that implements that really sort of corner case policy.
What's really neat with this policy, Jonas, is that the policy is always in place. Whether the physician is on vacation or not doesn't matter, because you do the time check. So it's not like you have to update the policy when the physician goes on vacation. No, it's always there. And that's a key difference with more static access control frameworks like role-based access control, where you would have to add and remove privileges as people go on vacation or do not go on vacation.
Right. So that implements our two policies.
Jonas, on line 39 you wrote write, but I think you meant update.
Correct. Thank you.
You're welcome. Cool. Really neat demo. So very, very quickly, before we move to a Q&A, let's just discuss a couple of best practices around your policy authoring. One thing we've noticed over the years, I mean, we've been doing this for the past 8 years with Fortune 500 customers. It's important to put your most commonly used policies first. It's more efficient, and it's also easier to manage that way. And you also want to think about general use cases that will apply to 90% of the access being granted or denied. For instance, in the example that Jonas was writing, doctors can view medical records they are assigned it to. That's the bottom line rule. As a whole, doctors can view medical records if they have a relationship with the patient. And then you want to start thinking about negative use cases. For instance, deny access outside office hours, deny access from outside the United States, deny access from a non-trusted device. And one thing that Jonas also mentioned early on, although we didn't use any in the examples here, it's advice and obligations. These additional statements you can add to a policy that will be returned with the decision from the decision engine to the policy enforcement point, so that you can enrich your business flow. You mentioned break the glass, Jonas, in your example. So one case could be deny the doctor access to the medical record, plus send them a break the glass message saying, if you do want to get access, then press this button to break the glass and get access. Or in the example on this slide here, deny access outside office hours, plus report on the reason for denial. So one thing we've noticed is that in authorization systems, it can be quite frustrating not to know why you're getting access denied. With ALFA, with XACML, you can actually return the reason for denial, and then people will know what to do in order to get access. Now, one more thing we're going to show you very briefly. Actually, we can just mention it and not do a live demo for in the interest of time. Is that Axiomatics provides the ability to deploy policies programmatically. So the point here is that you, as a developer, you write your policies using ALFA within your Eclipse IDE, and then we provide a plugin, a Java plugin, to push those policies dynamically to the Axiomatics Services Manager, which is our web portal for the authorization management. And that goes over a SOAP API. So you can create your authorization domains, and then you can push those policies to that authorization domain. And once you do that, the policies are propagated automatically to the different policy decision points. So in that way, you achieve programmatic, centralized management of your authorization services, and you can get deployed in minutes. It's great for testing and Q&A, and then migrating to production environments.
And if you actually have the code ready for it, you basically have to run. You have to run the code, and that will actually upload the policies.
That is cool. So we're looking at the console in the bottom part, right?
Yes. You can see down here in the bottom console that it's actually now already connecting to ASM. It's picking up the status from the PDP that's in place, and you can see here that we got the two core policies that's wrapped in the global policy already uploaded to the domain right now within my demo environment here.
Wow, neat. That was fast, Jonas. Cool, thanks. Okay. Do you want to try to show a quick the enforcement point, or should we just go ahead and move on to the Q&A?
I think we can quickly show one scenario in the enforcement point, just to showcase what this could look like here. So we have a sample application, and the requester ID here is going to be the Dr. Alice, and she's looking at reading a medical record, and she's a physician, and that should be enough, right? Because we are a physician that is looking at reading a medical record, and as we could see before, that was okay if you are the primary physician for the actual user. So we also have to pass in and say that, yeah, the primary physician for this medical record is Alice. Now, bear in mind that this is faking it, right? Because we're passing all the attributes in as part of the request here, whereas normally this is what we talked about before, would be resolved at runtime based on key attributes that are passed in instead. But if we send this to our engine now that's holding the policy that I just wrote, we get a response back, a permit response.
So if we sent Bob instead of Alice as a primary physician, we would get access denied, or?
Exactly.
Yeah.
So now you can see that we get an access denied back as a response. So if we test the corner case policy real quick, we can say that, okay, well, the primary physician is Bob, but Bob is on vacation until he's on a really he's on a really long vacation, a very long vacation. So he's out, right? But if we say that the alternate physician is actually Alice, so what's happening now is that Alice is requesting access to the medical record. Bob is the primary physician, but Bob is on vacation. So if Alice is an alternate physician, she should get access, right? And she does. Well, let's say that Alice is not on the list of alternate physicians, then Alice will not get access.
Awesome. Great. Thanks, Jonas. And we've got a few minutes to wrap it up with Q&A. I think we powered through like a train at the end, and this was a really great demo and really neat simulation at the end as well of the authorization requests and responses. So, Jonas, I've got the questions open up in front of me, and I've already answered to a few of them while you were doing the demo. But here's one for you. Can a XACML policy set developed by another product be imported and modified by the Axiomatics point-and-click tool? Can a policy set created in the Axiomatics point-and-click tool be imported and modified in ALFA?
So those are essentially two questions, right? But any XACML 3.0 conformant policy can be imported into our point-and-click UI tool. However, it's not possible to reverse it, because it would essentially be sort of reverse engineering a XACML policy into ALFA, right? That capability is not possible, although in some ways it's mostly about parsing information and parsing data, and I think we have actually some customers that have tried to do that themselves. It's not It's not something that we offer as a product, but that doesn't mean that it's not technically possible to do it. I think like I said, we have customers that have looked at doing that, and I think have successfully done that. But it's not possible within our tooling to reverse engineer it that way.
It is actually coming along. We will be able to do that in the future. That was my secret trump card that I had in the back of my pocket.
Yeah.
Here's another good one, Jonas. What's the difference, the bottom line difference between XACML and ALFA from a language perspective? Well,
we can actually showcase that with my Eclipse here. So we can see, you can see here. Well, you saw the code that we wrote, right, in ALFA that we did throughout the webinar here. Now, that is represented by something that looks like, we can do medical record. Let's do the physician access one. This is the actual representation in XACML of the same ALFA code that we just wrote. And you can see that this is much, 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 much more verbose and obviously very complex to read. And if you would write this by hand, you're probably very prone to errors versus actually defining it in the structure that we do in the ALFA code. So ALFA code brings it up to a much higher level, just like how Java and C# is bringing up,
low-level languages.
Exactly.
Yeah. Thanks, Jonas. And it's the top of the hour. Perfect timing. I want to thank everyone. I want to thank you, Jonas, for taking part in the webinar, and everyone else who's been attending. Thanks for the many questions. There's a few other questions we haven't tackled that we'll answer in writing. And stay tuned for more webinars. We have another webinar coming up next week at Axiomatics that will focus on healthcare more specifically. Again, thanks, everyone. Thanks, Jonas, and have a great day.